how can you make sure that there are at least two different addresses? This is logic basically.
Yep.
You're writing logic at this point.
Okay.
How would you make sure that the addresses are different? What kind of a function would you write?
Uh, I mean, it would be some type of find or map over. Um, yeah. Uh, I would look for a utility that says I want to find two different. Uh, I think we're in the right spot. Like check out inspecting all and I think count might be where it's at.
So when you do count, you're getting like a bunch of different outputs.
Okay.
Okay. Say you'll get like three outputs or whatever, right? Now, what will you do after that? You got the number three is what you have. Then what?
Hmm. Then it would.
Ahmed,
Well,
do
it'd
you
have to
have
be.
any ideas? Or Ahmed or
Oh yeah,
Ahmed or Lewis?
Lewis. Yeah.
How would you make sure that the list of outputs has at least two different addresses?
My first guess would be to use kind of write like a find function.
Mhm.
Yeah, but our problem now is how to identify addresses that are unique. Um,
Yeah.
Exactly.
cool. Uh, I'm still thinking.
No, that's totally fine. Yeah.
Yeah.
Um, so find function makes sense if you know the exact addresses here, but here currently we do not know the exact addresses. So let me try and figure a way out. The first thing I want to do is loop over the list of all the outputs. Okay. So how do you loop over the list? Uh, push, repeat, delete, drop, extracting, tailspan,
Oh, maybe
slice,
mapping.
filter, map. Where is map? Oh, mapping. For each. Okay, let's look at this. Index map for each. For each, you are doing something. I think this is what it's saying. For each element of the no, for the list, for each element of the list, do something.
Yeah.
Okay. Let's see what we can do. Or when you see map, Newman said map. Let's see what a map does.
Yeah.
Map takes the list and it takes a function and it starts mapping it with that function. So it's basically saying n plus 1. So all of these. Okay. Interesting. I feel like that will be a
No, I
good
don't
thing
know.
to do. What I would want to do, the reason
Oh,
I like the map is because of this. What I want to do is I want to create a new list with only the addresses. Okay. That is step one. And once I have this new list, what I want to do um, is there like something that matches? Um, is there, I want to see if there's something. Okay, let me quickly write this logic. I mean, we can always delete it if it doesn't make sense. What are we doing? So you're using map. Um, okay, cool. I'm gonna import map here.
oh man.
Use Cardano Aiken list. I'm gonna, so this will get all of them, right? Okay, cool. So here, what we'll do is we'll start mapping. Um, uh, this is absolutely like this AI thing is pissing me off. Map outputs. Function output dot address. Exactly, that's what I want. How did it know? Sometimes it knows everything, sometimes it's too dumb to know
Right,
anything.
right.
So what this is doing is it's basically creating another list, a new list with all the addresses, right? 1, 2, 3, 4, n plus 1, this becomes 2, 3, 4. Yeah, so it's basically creating a new list. Let me call this let address output address list. Output address list equal to list.map. Yeah, I think let's say list.map. Okay, so we have a new list. Why is this looking like this? Okay. Uh, is there like a unique? It is suggesting some unique, but I have a feeling there's nothing called unique for
Um,
list.
yeah, I saw something, but
Has
it's
is it
lower down than that. Let's see. It's in the
unique here? Let's see what this is
yeah.
doing. So it takes a list, removes duplicate elements from a list.
So what I was thinking here is that if you list unique it and compared if that changed it. So if you got the list length and then you ran
Hmm.
list unique and it changed it by one, then you would know that there was a unique. I don't know. I don't know. It's
Yeah,
just a
no,
little
that,
bit of
that makes
logic.
perfect sense. No,
Yeah,
at least for me
something
it
like
makes.
that. There's a ton of different ways to do it. For instance, you could, if you just think about it like logically without, without trying to figure out the syntax at the same time, what we could do, because we basically have a list. And if you
Mhm.
think like a computer, how would you look at and find out if there were at least two uh, that were the same? Is that right? No.
No, I
We
think
need to
for
find.
me at least what you're saying is making sense.
Okay, okay. Well,
So
I'll leave it at that. I'll take the win.
yeah, so for example, what you're saying is now you have output address dot list, right? Um,
Yeah.
and they're saying unique basically takes this list and gives like unique thing, right? Okay.
Right.
So
So
now,
it takes a list and it produces a list.
yeah,
So it takes the first list and then it makes a second list. So you can say,
exactly,
right.
exactly. Um,
And if they were,
so and if they are equal,
then there's not, it's not
oh, there is another
there.
way of yeah. So that is one
Yeah.
way, and I like this way as well. If this unique list has a length greater than 2, then it should pass. You get what I'm saying? That means there are at
Yeah.
least
Because,
two output addresses.
yeah, exactly. Exactly. Because then it says there are two unique addresses.